All right, let's dive into this explainer on Erwin Schrödinger and the absolute revolution of wave mechanics. So picture the scientific environment of the 1920s. Our entire view of reality was literally fracturing. It was totally chaotic, driven by a dizzying, rapid sequence of brand new quantum developments. Physicists were totally stuck. Heisenberg's matrix math worked, sure, but it was abstract and impossible to visualize. Then, Louis de Broglie dropped a bombshell idea. What if matter particles actually exhibit wave-like behavior? Seeking a smooth, continuous description, Schrödinger built his famous equation to govern these bizarre matter waves. Talk about a massive paradigm shift. Schrödinger finally offered a physically intuitive alternative to those abstract matrices. Wildly enough, physicists later proved both of these radically different formulations were actually mathematically equivalent. Now, the absolute beating heart of his new mathematics was something called the wave function. Schrödinger thought it was a physical wave, but Max Born realized it actually represented probability density. Here's the crucial takeaway. Quantum mechanics predicts mathematical probabilities rather than rigid classical certainties. This completely shattered our view of atomic orbits. Electrons definitely aren't tiny planets in fixed circles. Instead, Schrödinger proved they exist in cloudy probability distributions. He literally replaced physical certainty with mathematical likelihood. We call these fuzzy probability clouds atomic orbitals, specifically categorizing their shapes as S, P, D, and F. These exact orbitals dictate literally everything we know about chemical bonding, structure, and the periodic table. To criticize naive interpretations of this bizarre probabilistic reality, he proposed that famous cat thought experiment. It perfectly highlights quantum superposition, where a system exists in multiple states simultaneously until formally measured. Ultimately, Schrödinger's wave-particle framework became the absolute bedrock for modern chemistry and all our quantum technologies. His math did have limitations, though. It wasn't relativistic, a messy issue Paul Dirac later solved. Leaving us with this provocative final thought. If atoms are just probabilities, how solid is our world really?